Welcome to the world of machine learning. What we will try to see in the next 10 minutes is what is this machine learning is all about. You may have heard about machines constantly learning on its own. So what does that mean? Uh, does it really happen that way? And how will we even know that if the machines are constantly producing predictions, did they get it right? And if they get it right, that's fine. But what if it was wrong? Who are going to inform the machines that they were wrong, and will the machine correct itself? So these are some of the questions that we will attempt to answer in the next 10 minutes. To begin with, let's look at what is machine learning. Machine learning is basically a computer algorithm that reads data, it learns from it, it identifies some patterns in it. Now, there are different types of algorithms which has varied approaches to identify the patterns. So what are these patterns that we are talking about here, and how does it make sense? For instance, you could ask an algorithm to figure out the mileage of a car. So, intuition tells us the mileage could be impacted by the weight of the car, perhaps the horsepower of a car, maybe the number of cylinders. We could look at whether it's an automatic or manual car. We could look at number of gears. We could see if it is a V engine or a straight engine. And we could look at many things, the conditions of the road it is being driven, which part of the city, which part of the country. Let's assume that we have collected number of data points, and what we could do is we could give it to a machine learning algorithm, and we could say, here is my target variable, here is a combination of many input variables, have a go at it. And there are many techniques for us to call. Let's assume that we are able to call one such algorithm. What it does is it looks into the data and it formulates some kind of a model, identifies some patterns, and then it come back to us with an answer. We could also look at another algorithm where we are looking at identifying employees who are more likely to quit. This is again based on past data. So assume that you have a database of employees. Some of them are still in the system, some of them have moved out of the organization, and you kind of want to understand, what is the difference between these two groups of employees? Employees who are still here, employees who are quit. Now, what kind of employees are more likely to quit? And again, you could think of number of reasons like their overall experience, number of years in the current role, their past performance, incentives, do they travel a lot, the distance from their office to their house, uh, were they stuck in their current role for a long time, or the current designation, is there any competitor opening shop close by, and so on and so forth. Now, you may do simple exploratory analysis to identify key indicators. For instance, you may do a correlation or an equivalent in comparing employees who have quit and who are still here, perhaps with the distance of travel from their house. Or you may compare it with the years that they have spent in their current position. And you may see a pattern. People who are at the same position for longer time, they are more likely to quit because maybe they're not getting promoted or recognized, so they're moving out. Now you may get this information from a simple exploratory analysis. You don't need machine learning for that. But then you kind of understand that's not the only reason. There are combinations of many reasons. Maybe it is a combination of distance from the office to the experience to being stuck in the same position. Or it may have nothing to do with that. It might have everything to do with purely the number of travel the employee takes. It might have to do with the specific department where the employee is working, and which may be different for different employees. Now, while exploratory analysis gives you an idea that these are potential indicators, but how exactly do they matter in terms of the final decision? That a machine learning algorithm will be able to find. So these are some of the examples. But to get a little bit more closer to the information, to make it easier, I've kind of formulated some of the business problems that you will come across and what kind of machine learning algorithms exists. So broadly I'm calling them as techniques and there are some algorithms. So just to differentiate between those two, what it means. So let's take some simple business problems. Let's take you have an issue with the cost structure in your organization. Maybe you are overrunning your costs more often. Maybe you have a problem with margins. Maybe you have a problem with revenue. Maybe you're trying to find out the price of a second-hand car, or you're looking at viscosity of a tire, mileage of a car. Maybe you're looking at identifying the number of customers who will come into your shop based on a campaign that you do. One commonality for all of these problem statements is that the problem statement, which usually starts with a target variable of interest, is numeric in nature. For instance, mileage could be a number from 10.x miles per gallon to maybe 40 miles per gallon or something like that, or even more. Cost is basically cost structure within an organization. What percentage of your revenue is cost? Now, what we are trying to do with this is that number could be a number theoretically from minus infinity to plus infinity, but practically a more meaningful number based on your business. Is numeric in nature, continuous numeric. If you end up with a problem statement or a business requirement where the target variable is numeric in nature, then the kind of techniques that we use, we call them as regression or equivalence. And some algorithms or they take a different approach to applying these kind of problems. So there is something called an ordinary least square technique, which is also called as linear regression. We have variations to that like ridge or lasso or elastic net. We also have alternate approaches like decision tree algorithms or random forest. You could perhaps look at neural network. There are various techniques available for us to do a problem solution where the target variable is numeric in nature. We call them as regression suite of algorithms. A second scenario is instead of a continuous numeric value, your target variable is a choice. It's a set of categorical values. So whether an employee will quit or stay, you have only two choices. Whether somebody is suffering from a serious disease or it's just they're all right. It could be whether a loan will result in a default or not. The risk level of an insurer, which could be low, medium, or high. There you have a set of choices. Now, most of the problem statements tends to be two choices. Sometimes you may end up with three or four, quite rarely higher than that. So when your target variable or a variable of interest, which is basically derived from your problem statement, is categorical in nature, the set of algorithms that we use is called classification. And again, there are a number of algorithms like logistic regression. Um, we have random forest, neural network, XGBoost, light GPM. They all play their roles there. Sometimes you're not just dealing with the target variable. You're perhaps looking at a scenario where You're looking at a specific scenario where you have input data and you're just trying to find out there are hidden patterns. For instance, if you have gone to Amazon sites or Flipkart sites, people who have purchased this also purchase this. So that's called a recommendation engine. One of the input to the recommendation engine is something called as a market basket analysis, where you're looking at products that are typically purchased together with other products. You may not necessarily have a target variable, but then you're looking at association between products. Another area where we would do a similar kind of grouping of customers is called as clustering. Based on similarity of customers, you want to put them into one group so that you can do email campaigns or something. So a bunch of areas where some of these techniques will also come into play. And we have these algorithms like K-means, hierarchical, a priori, or quick growth that play in that. These are again grouped together. If you have a target variable, they're called as supervised techniques, on which you can usually train and test the models. The second category, which is the last row item, is called unsupervised learning techniques, where you don't have a target variable, you're merely looking at your input data and trying to find some hidden patterns. Now, these are some of the techniques, machine learning techniques that we apply depending on the problem statement.